So, this is the second take that I've done of this over a 3-day period, so let me see how I do with this one. The question is, why was I so contrarian associated with the simulation methods that I used with the Noble Ape simulation when I first started developing it back in 1996? So some background to this, particularly for those who may need to Google the term contrarian. Let me just put this out. I decided when I started Noble Ape to use simulation methods with regards to cognitive simulation, but also with regards to biological simulation, which had not been used previously. For the biological simulation, I used quantum mechanics to simulate the biology. And for the cognitive simulation, I used an Agar algorithm associated with information propagation, which I mapped onto ideas called identity. Well, identity is the whole thing, but fear and desire were the two underlying components of the cognitive simulation. And initially, I didn't include a variety of scalar values which most people would include in these kind of simulations. Things like, well, for example, fear. I mean, fear is not the raw fear emotion or a quantifiable version of fear. It's how it actually works with the Noble Ape psychology. So, since Brazil's work, there were 4 scalars. Sexual attraction. I can't remember the 4. I never can remember the 4 when I have to come up with them. It's called the scalar anxiety. Sexual attraction, shelter, I think, is one. Food, shelter, food, society, maybe? I don't know. There are 4 values. I really should consult the code before I start this. So, when I started developing Noble Ape, I wasn't interested in doing anything like Synth Brazil stuff or anything like neural networks or stuff like that. I'm recording this on a Friday evening, so I'm necessarily slower than I would normally be in terms of discussing these topics. But I needed to get this video out. So, when I started Noble Ape, I had an existing body of work, including Agar petri dish simulations and antiviral software, compiler software, 3-dimensional landscape software. And in addition to this, I brought on the biological simulation based on quantum mechanics, underlying noise maps, these kind of things. And I created 2, like an internal cognitive simulation and external landscape simulation with biology, which I thought at the time was relatively unique. And in contrast to this, I think is Larry Yeager's Polyworld. And Larry Yeager's Polyworld had similarities, a number of similarities, but Larry Yeager followed neural networks, and the biology was relatively straightforward, and foodstuffs kind of grew in place. Through, well, I was still in Las Vegas, so that was a time frame on it, probably 2008, 2009. I worked on taking Larry Yeager's Polyworld and Noble Ape and combining, mixing and matching the various parts. Just because I was interested in taking a simulation which was similar and using aspects of Noble Ape. I think what I wanted to do was to take the Polyworld, they're called sea monkeys in Polyworld, I think they're called sea monkeys, and put the sea monkey brains into Noble Apes. And that was an interesting project. Like I said, it took about 18 months. And in parallel to this, Bob Mottram was also adding the work of Synth Brazil, also event and social graph simulation, basically a lot more kind of quantifiable stuff, a language simulation Bob Mottram added. And this is 2008, 2009. But when I started developing Noble Ape, I wasn't interested in any of that. I was 19, I was angry, I wanted to show whatever I thought of the world at the time, that one could create rich, detailed philosophical simulations with relatively primitive concepts and just put it all together. And then that Tom was no way interested in, reaching out to academia or doing things with existing academic things. I was interested in taking stuff that I'd developed, tools that I'd developed through my life, basically, writing antiviral software and compiler software and certain kinds of game software. And then adding a few additional ideas like I had, like the biological simulation and quantum mechanics. So, to explain this, if you imagine that you have a landscape, there are certain properties of that landscape which enable plants to grow and animals to flourish in various areas. And you have like the sunlight, and then the total sunlight and the rainfall. And then if you imagine just surface area, so if things are flat, this is the reason that, when people have pastures and, when they're growing corn, they're not growing corn like this, right? They're growing corn when it's flat. So the corn comes up, the sun goes over, the corn gets the maximum possible solar energy. Whereas if they were on a tilt like this, the corn wouldn't be growing that way, right? So there are certain plants that like on the tilt, certain plants that like on the flat. So you can start simulating plants just based on those kind of things, and height and, water and rainfall and moving sunlight. And then you have a bunch of animals like insects, for example. Like insects like shadows typically, or to live in the shadows in certain areas. So you'd have certain insects that would track the shadows, and then other insects that wouldn't track the shadows. And then you can create, it's a probability map, basically. What you're doing here is you've got one underlying wave function, which is what's described in quantum mechanics, which is just the landscape. And then you can get the surface area and the height and water characteristics and a bunch of other things from that. Then you combine them together. You either sum them, subtract them, certain things, and then you have a probability of there being ants, or a probability of there being grasses or berry bushes. You have all these probabilities, and then you have a noise map, which in the case of the plants is static, in the case of the animals is moving. And when the noise map pierces the probability, that's where you could say pretty definitively that there's probably going to be a grass there, or a series of grasses, or a fruit tree, or, ants scurrying, all this kind of stuff. And that was the biological simulation. The cognitive simulation I've talked a little bit about previously, but there was two competing mathematical notions with sensors and actuators, and the way the mathematical notions interacted was the transmission point between the sensors and the actuators. And that was the cognitive simulation. And that was good up until about 2005, when I introduced ApeScript. And with ApeScript, I gave the ability for people to write their own cognitive simulations. They could write their own philosophical, the idea of Noble Ape is really a philosophical clearinghouse. That you can take various ideas in philosophy, and if they're not explicitly written already in Noble Ape, you can write them in ApeScript. And ApeScript was the notion of each time cycle was a programmable cycle in ApeScript. And you could follow long paths, and, it was basically a way of capturing state in one regard, but also allowing a cognitive simulation to exist next to state as well. So, let's return to why the road less travelled. My sense when I started Noble Ape was that there were a bunch of things that hadn't really done stuff that I wanted to see happen. I mean, it was, in some regard, a philosophical dare. It was a sense that, could this be done? Dare me to do it, so to speak. But actually, behind it as well, there was a sense that the frequently travelled path wasn't actually yielding anything that was meaningful or interesting to me. So let's go off in some different direction and see what happens in that direction. And then I've oftentimes referenced Noble Ape as being philosophical satire. It's the notion that when you take, 3 or 4 different philosophical methodologies, and rather than saying these are competing or opposing, you get them intercommunicating, you get a beautiful gestalt. You've got all these parts, sum them together, more than the sum of the parts. And that is something that I've taken out of Noble Ape very solidly, that you shouldn't think of philosophy as being, academics are very good at creating their little silos and then flinging stuff from silo to silo. But actually, if you think of these things not in competition, but actually working sympathetically together, you get a wide variety of different artifacts from that that are actually considerably more interesting. So, when I periodically meet academics and they chastise me about Noble Ape not being science, I say, wait, it's not science, it's philosophical satire. That's why I'm doing Noble Ape, not for science, if we get science out of it. But the philosophical satire is good. So anyway, that I guess is the way that I can maintain this notion of still not travelling the path most travelled with Noble Ape.